Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, our topic is about location intelligence. This topic is based on a tech blog written by data scientists from Walmart with the title Geospatial Search Made Easy. The blog link is shared in this episode description if you want to take it for reference. From now on, I will break it down from both a business and a data science perspectives. Let's get started. The first question on the business side is what is location data and geospatial search? Why they are important? Take a look around. If you can find any smartphone, then there would be some GPS signal associated with the smartphone. Then it could log the latitude and longitude location of your place, and that is one of the geolocation data. Look around the corner, see whether there is any restaurants or grocery nearby. Those restaurants and groceries, they also have their location data available, so that usually we can see them on the maps. So as you can see, location data is everywhere. There are many general applications around the location data, and they are very important for us to make decisions. For example, if you are trying to go to a different city or trying to call for a taxi, then the geolocation data is helping us to make decisions on the right routing. And if you may be using some social network apps, there are features like nearby friends. Then you can easily find your friends nearby and hang out together. For the Walmart case, the author stated that the purpose is to find all the retail stores within the given radius of a user. This is only one example of the business. I'm sure there are many other applications around this part, but let's take this as a business need for now and turn on to the data science part. From the data science perspective, given the geolocation data of the users and all the retail stores, one question is how to calculate each pairs of the user and the store's distance. If this is in a two-dimension space, like we have the x and y coordinates, then things are much easier. You will just need to calculate the difference of the x coordinate, the difference on the y coordinates, and use the delta x squared plus delta y squared, take a square root of that. That's the distance between the two spaces. However, the Earth is round, and we live on Earth. So not surprisingly, if the information provided is the latitude and the longitude information, we cannot view it as a two-dimension space. That's where some trigonometric functions will be involved. And the specific formula to calculate the distances over a 3D dimension is the Haversine formula, where it involves some sine, cosine functions, and those functions will make the 3D distance calculation more accurate. However, on the other side, the Haversine distance is much more time-consuming to calculate than the two-dimension space formula. But it is usually more accurate because it truly reflects how things look like on a 3D surface. This is the formula where the team proposed to have. On the other side, the Haversine distance is much more time-consuming to calculate. So it may not be very practical to be calculated in all the places. Although this is not stated in the blog, but to my personal experience, if those two locations are very close to each other, then you can just use approximation, basically approximating the 3D space into a two-dimension space, and then use the x and y coordinates difference calculation. Although that one is not specifically discussed in the blog, I think it is helpful to always for us to keep in mind when the accuracy is needed the most or where the speed is more needed. Now we talked about how to calculate each pair of the user store distance. There is still one extra challenge involved. Every time a user wants to check the nearest retail stores, then it involves to calculate the Haversine formula between this user and all the retailer stores. And that is very costly, time-consuming for each of those, and also this is unnecessary. So that's where the team introduced a bounding box approach, where given the user already input the search radius, then you can looking for the maximum and the minimum of the latitude and longitude based on the location of the user. Then you can filter out all the stores outside of this bounding box and only calculate the distances between the stores within this bounding box toward this user using the complicated Haversine distance formula. This will make the calculation much faster. Well, this bounding box methodology may appear simple and straightforward. This overarching concept of filtering out a subset of the candidates and then perform more complex calculation within that represents a commonly employed approach in real-world scenarios. If there is a huge amount of candidates pools to be either ranked or searched or to be compared with, then this approach is usually a much more reasonable route to go rather than doing the complicated calculation over all the space. Now we talked about how to calculate a two-point distance on a 3D location, and we also talked about the idea of the bounding box. There are some extra tips suggested in this tech blog, and I find those to be very interesting and useful. These tips were proposed because they will make the computation even faster and more efficient. So let's take a look at these tips. The first one is to pre-processing the data for geocoding. Because if every time the geocoding data need to be processed, then that would be very time consuming. So pre-processing this geocoding data, store it in a place, and then only retrieve the necessary information for the calculation would be much more efficient. The second tip is that during the implementation stage, it's very helpful to think about how to do multi-threading or parallel calculation to filtering out the candidates. If there is a huge pool of candidates, multi-threading or multi-processing will make the time much more faster. The third tip is that if you're implementing the search as a database query, then leveraging the indexing of the columns can significantly increase the speed of the geospatial search. To wrap it up, in this episode, we take a look at how the data scientist team at Walmart makes geospatial search easily used on their platforms. We discussed the business perspectives for why location intelligence is important and why geolocation data is everywhere. We talked about the Haversine formula and the widely used concept of filtering first to get a subset, then run heavier calculation later. If you like the content of this episode, please subscribe to the channel, give me a 5-star review, and leave a comment. Your feedback is very appreciated, and I'll see you next week.